All right, let's just jump right in. We are going to take a really hard look at a huge scientific idea, one you definitely learned in school, a law that seems to predict the end of, well, everything. But what if that story we've all been told isn't quite right? What if the problem isn't with the physics, but with the words we're using?
I mean, you've heard this, right? It's so dramatic, so final. The second law of thermodynamics, we're all taught, means everything is slowly grinding to a halt, heading for this final, silent state where nothing interesting can ever happen again.
And this story, it's everywhere. It paints this picture of a universe that's just bleeding out, constantly losing useful energy, where order just crumbles into chaos, and everything is just decaying into this useless cosmic sludge. It's a really compelling story, but it has a massive, glaring problem.
Okay, so first up, the official story we all know. This idea of a universe that's winding down, like an old clock.
But hold on a second. If you really think about that story, it smashes head-on into another law of physics, one that's even more basic. There's a huge contradiction here, and it's hiding in plain sight. So let's just really stop and think about this for a second. If one law tells us that the total energy in the universe is constant, that it can't be created or destroyed, how on earth can another law tell us that this very same energy is being permanently lost? Logically, it just can't be both. And when you lay it out side by side like this, wow, the conflict is just so stark. On one hand, the first law says energy is eternal. It just changes shape. On the other hand, the story of the second law says that energy turns into useless waste, that it's effectively gone. I mean, these two ideas are in a total brawl with each other. And here is the absolute key. The math of thermodynamics works. It's perfect. The equations make predictions that are spot on. So the problem isn't the math. It's the language. It's the metaphors we've used to explain the math. The story is a lie, but it's a linguistic one, not a mathematical. So how did we get here? Let's dig in and see how our choice of words completely twisted the actual meaning of the second law. Okay, this right here is the whole ballgame. We use these heavy, final words like loss, waste, decay, death. But the math isn't describing an ending at all. It's describing a process. It shows energy being redistributed. It shows systems reconfiguring. It's talking about a statistical tendency, not some ironclad cosmic death sentence. And this is where we all get tripped up, the idea of entropy. We're taught to imagine it like this giant cosmic trash heap, right? Energy that got used up, and now it's just junk, forever useless. But the reality is so much more elegant, and honestly, it makes way more sense. Entropy isn't about destruction, it's about distribution. It's simply a way to measure how spread out the energy is in a system. That's it. Nothing was destroyed, it was just rearranged. So let's get the story straight. Let's talk about what's really going on. Because energy, well, it never actually dies. Let me ask you a simple question. If you've got a solar panel on your roof, but it's pointed away from the sun, is the sunlight itself wasted? No, of course not. The energy is still there, pouring down from the sun. The energy is fine. The problem is your system for catching it. It's really simple, right? You point the panel at the sun and boom, you get power. You're doing useful work. Then you point it away from the sun. Now, from your panel's point of view, that exact same energy is suddenly wasted. But then, just point it back and presto, you're making power again. The potential was never, ever gone. And this is the big, central idea right here. The energy didn't change one bit. The system did. So being unusable isn't a property of the energy itself. It's just a description of the relationship between that energy and whatever's trying to use it. The potential isn't lost. It just depends on the configuration. And this isn't just some clever little analogy. This is real. We can actually see this principle in action in some of the most extreme places you can imagine. Think about a place like CERN. Physicists there take what seems like totally diffuse, disordered energy, and they apply these incredible new constraints. Bam! They smash particles together with insane amounts of force. And instantly, out of what looked like total chaos, new structures just appear. New particles, new gradients, even mass itself emerges. The potential was there the whole time, just waiting for a new set of rules to be applied.
So we have to throw out that old grim story. The universe isn't running down. It isn't a dying clock. It's an unbelievably dynamic system that is endlessly, ceaselessly reconfiguring itself, always finding new ways to express structure and order.
Okay, so why does this all matter so much? I mean, it's just words, right? Well, no. It's a huge deal because it gets to the very heart of how we learn and what we decide to call knowledge.
You see, when the language we use to teach flat out contradicts the math it's supposed to be explaining, we're not actually teaching. We're certifying misinformation. We're handing students a contradiction and telling them to memorize it. That's not understanding. Real mastery is about resolving contradictions, not just repeating them. And this quote from the source material, man, it just hits so hard. It forces you to ask, what is education really for? Is it for rewarding people who can defend a broken idea? Or is it for rewarding people who can actually resolve the problem and find the truth? Because that credential might just be measuring compliance, not understanding.
And that really leaves us with one final big question, doesn't it? If a concept this fundamental to science could be distorted by bad language for over a century, what else might we be getting wrong? What other big truths might be hiding right there in the math, just waiting for us to find better words?